Hello everyone. Let's start this session to know about the efficiency, system performance and user convenience. We have said that the goal of an operating system is based on its efficiency to use and how convenient for a user it is. Now, the computation of an operating system can be categorized in two ways. One is a non-interactive environment and the other one is interactive environment. The non-interactive environment says that whatever the computation you want to work, you have to give it to the operating system and for the processing, and you have to wait for the result, and based on the result you can say that how efficient your operating system is. Right. Similarly, if it is for interactive environment, a user can ask for a computation with his or her own program by requesting, by sending an sub request, and for how easily or how effectively you are getting the response for that particular sub request decides how efficient your system is or your operating system is, right? So based on how quickly we are getting the response, we can categorize this computation into non-interactive and interactive environment. In non-interactive environment, the response is based on the number of programs or jobs or whatever the processes we are assigning to the operating system, how effectively it is working and how quickly we are getting back the response. If it is with respect to interactive environment, how quickly the request has been response, based on that we can say that how efficient your operating system is. Now you can see that here in non-interactive, the computations can be classified as programs and jobs. So we know what is a program. So a program is nothing but set of instruction to perform a particular task, right? So set of instruction, you can say set of functions or set of modules. Whereas job is nothing but a sequence of single program, we say. A single program is a kind of computational structure where the programs what we have put in that particular single program, it will be executed in a sequence manner, in a sequential manner. For example, you can say you know about the compiler, linker and execution. The linker or the linking operation will not be done until and unless compilation is done. Similarly, execution will not be done until and unless linking and compiling has been done. So the linker will work only when compiler has finished its work, right? And the execution will work only when the linker has finished its work. For this linking, the input is from output of the compiler, and for the executor the input is from output of the linker. So this is a single program example where all the programs are being executed in a sequential manner, nothing but one after the other. Executing a linker in the first step, it is really meaningless because you have to execute first compiling. You have to make your compiling done. Once compiling is done, then only you can go for linking, and once linking is done, then you can go for execution. And this kind of program we call it as a single program. Similarly, we have next as a process. A process is again an execution of a program. So now a program, a process or job, how easily they are executed and getting back in their response, that is going to happen in non-interactive environment. If we are coming for interactive environment, we just a user will interact with his or her own program. Here a user may request any computational request for the processing to an program, and that request we call it as a sub request. Now what and all the key concerns we have discussed now, like program, job or process, we have just made it on in a table. You can see that computation, what is the computation, what is the description we have written. So program, so we said that program is nothing but a set of instruction, maybe a functions or modules. Sometimes maybe the computational instructions we are getting from the library. Next computation, we have a job. So a job is nothing but a sequence of a single program. The example you can say about compiler, linker and executing. Next we have a process. A process is again an execution of a program, and sub request is a request made by the user for a computation with his own program. Next we have to check out how you can measure the efficiency, performance and how user convenient it is. So we say the efficiency is based on how quickly we are getting the response by using the available resource, nothing but effective utilization of the resources. Based on that we have to work out for any computation and we have to get back the result in a good manner. Then we can say that how efficient it is. Whereas the system performance typically measured with the help of the throughput. So So throughput, we say that how quickly we are getting the output per unit time. So with respect to this operating system, we say that throughput is defined as the number of jobs or programs or process which are going to execute it per unit time if it is non-interactive environment. Provided if it is non-interactive environment, the number of jobs or processes or programs which are going to be executed per unit time, we call it as throughput. If it is interactive environment, then we will say how many sub requests has been responded per unit time is called as throughput. So based on non-interactive and interactive, you can calculate your throughput, where throughput is nothing but the output what you are getting, the responses what you are getting per unit time. So user convenience. So user service is nothing but how convenient for the user to use that particular operating system. So that can be classified or that can be measured in based on the two key parameters. One is turnaround time and the one is response time. The turnaround time is nothing but the total time required for the initiation and termination of the job or a process or a program, whereas response time is nothing but how easily or how much time it is taken for a sub request to be processed and you have to get back the response. That is what response time. So user service is measured with the help of two key parameters. One is turnaround time and the other one is response time. Turnaround time says that the total time you require for a job initiation and termination, whereas response time is the time you require for the completion of any sub request. This is for user service. And for throughput, you can calculate based on your non-interactive and interactive, and definitely we know what is efficiency. So based on that, again we have made out a table. So you can see about the attributes, concepts and description. So efficiency of use is nothing but CPU efficiency, how efficiently your CPU is being used for any other different programs. So here the description is nothing but your percent utilization of the CPU. Similarly, your system performance is calculated with the help of throughput, and throughput is nothing but the number of work done or nothing but the output we are getting per unit time. User service is based on two concepts. One is turnaround time and the other one is response time. So turnaround time is nothing but the time you require for the completion of a job initiation and termination, and response time is nothing but for a completion of a sub request, initiation and completion of a sub request. Now next go with the next topic, classes of operating system. So these classes of operating system has been evolved based on the concerns, the prime concerns or maybe the deficiency we have looked for. For example, during the period of in 1960, we can say that the primary concern what we had for the generation of any kind of operating system was idle time of CPU. Nothing but we are not making your CPU to work in an efficient way where all this resource is being wasted. That's why we have gone for operating system of the type batch processing. And one of the parameters or one of the methodologies we have tried to implement this prime concern was spooling and command processor, which was happened in 1960. When you go for 1970, we can see that the kind of operating system we had is multi-programming, and again the prime concern we had it is for resource utilization. So how effectively simultaneous use of the different resources made us to go for multi-programming, and it has the key concept which were included for the implementation of this concern was program priorities and preemption. Similarly, we have time sharing, real time and distributed systems. For all these things we have the different key concepts and prime concepts. Just look into that. First one, we'll go with batch processing and multi-programming system. So batch processing is the first type of operating system which was evolved in 1960s, and the primary concern which was having was CPU efficiency. We were wasting the resource, CPU resource. That's why we wanted to make it in an really efficient. That's why we want for batch processing. In batch processing, we say that your CPU will be made to work all the time in such a manner that programs will be given back to back. For example, you will be giving program 1 to your CPU. The program will be worked, it will be processed and it will be executed. Once program 1 is done, next we will give program 2. Next we will give program 3. Like that, we make your CPU to work without making it idle. You can see here, initiating the next program when one program ends and the next job when one job ends, so that CPU does not remain idle. The overall motivation is we want your CPU to work all the time, so it should not be idle. How you can make? You can make it to work continuously by giving the programs or jobs one after the other. Here the efficiency of CPU was increased, but the time it took was really more, where it was like for a single program we were supposed to assign time, we have to wait for it until its completion, then you have to go for the second one, then you have to go for the third one. The next kind of operating system we came across was multi-programming. So this multi-programming is the prime concern for this was resource utilization. We just wanted to use the available resources, all the available resources like CPU, IO devices, memory simultaneously, where this resource of CPU was assigned to the programs based on the priority. Here it was like you had higher priority programs and low priority programs, and the CPU will be assigned first to the higher priority programs. Once this higher priority program starts executing its IO operation, the CPU will get back to low priority programs until the higher priority programs will finish off their IO operation, so that you are making your CPU to work simultaneously both on higher priority programs and low priority programs. You got me? So here we are saying that in multi-programming we are making the resources to work simultaneously on the different programs. The programs we are classifying as higher priority and low priority. The CPU will be assigned first to higher priority programs. When the high priority program starts executing their IO operation, the CPU will get back to low priority program until these high priority programs will end of their IO operation, so that you are achieving the simultaneous use of IO devices and the CPU. Next we have time sharing system. So here in time sharing system, all the sub request what we have made by the user, it will be given a quick response. It will be given a quick response. That is, we have to give the facility to get quick response to all the sub requests in time sharing system. For the execution of this time sharing system, we have two methodologies. One is round robin scheduling and the other one is time slicing. So in round robin scheduling, we say that the service will be given to all the processes on turn basis. Whereas in time slicing, your operating system will prevent any particular program to use CPU for a longer period. Got. So in round robin scheduling, we say that the operating system will give service to all the process based on the turn. Whereas in time slicing, the CPU will avoid any program to use a CPU for longer period. Based on these two concepts, it will give a time sharing system, time sharing methodology for all the programs, right? One is round robin scheduling and the other one is time slicing. Real time system. So the name itself is saying we want all the computation to be work in real world, to work for real world activities, right? Next we have distributed system. So distributed system says that any low cost computer system, a user who is using a low cost computer system can use the resources which are available on any expensive computer system. So based on all these operating system which have started evolving from 1960s, we have made a graph which is drawn against efficiency and user convenience, and based on the parameters we have just divided their efficiency. So based on necessity, we can categorize multi-programming and batch processing. In multi-programming is having highest efficiency compared to batch processing, because batch processing, it is used to make your CPU to work simultaneously by feeding a program, single program at a time, whereas multi-programming is one where many programs can work simultaneously. Similarly, when it comes for real-time OS and time sharing, we say that time sharing is having more efficiency compared to real-time operating system, because real-time operating system, again, it will work on a particular application. We just want that application to be done in a given deadline. And again, based on the resource sharing, we have a distributed operating system where all the resources can be used which are available on the other computer system. So distributed system is used for resource sharing. Time sharing and real-time operating system are used for good servicing, and multi-programming and batch processing is based on necessity. Thank you.